Okay, number 9 from section 3.3. A lot of stuff in this section. I don't usually do 4 problems, but I think this problem is kind of important because it's got an important fact in it. But let's see what the instructions are. It says, let S be the parallelogram determined by the vectors 6, 5, 6, negative 5, and 0, 1. So from the last problem I worked, the last video, you know the two vectors uniquely determine a parallelogram. And we said in the last problem that I worked that you would really just have to find the determinant of the matrix 6, 0, negative 5, 1 to find the area of the parallelogram. But what we're going to do is we're going to take that parallelogram and we're going to find the area of the image of that parallelogram under a certain linear transformation. Okay, here's our linear transformation. X goes into AX, but A is supposed to be 6, 2, 1, 1. Okay, so we're basically just going to take that parallelogram and map it into another space through this mapping. We're going to multiply it by this matrix. Okay, so every one of the points in that parallelogram is going to be multiplied by this matrix, and it's going to go to some other picture. So I don't know what the other picture is going to look like, but we need to use an important fact. Here it is. When a region is mapped under a linear transformation, the area of the new region, and I'm really talking about a polygon here, but the area of the new region is the area is the original area times the determinant of A, believe it or not. And I'm talking about this A. So just take the determinant of that matrix and multiply it by the area of the original polygon to get the area of the image. Whatever it looks like, who knows? But that's what we're going to do. Okay. So let's find the area of S first. That's the original parallelogram. So from the last problem, we know that's just the absolute value of the determinant of this matrix. So that's just going to be, let's see, 6 minus 0. That's just 6. So the original area of the parallelogram is 6. But now the new area, it's kind of a nice little fact. It's just the determinant of that A times 6. Okay. And the A is the matrix we're using in the mapping, which is 6, 2, 1, 1. So that's just going to be 6 minus 2. That's 4 times 6. Sounds like the new area is 24. So the linear transformation blew it up a little bit. It started out being area 6, and it blew up to 24.